So the second lecture of today is going to be given by Professor Neera Ganguly, who's in the Department of Computer Science in IIT Kharagpur. So again, Neela is a very old friend of mine. He's one of the leading figures in complex network science community in India. And we have actually co-hosted a NUB and meeting sometime back in Bangalore and so on. So one of the areas of interest is looking at use of language in various social networks online. And his research interest in fact span natural language processing, and in particular the use of machine learning in that context. So I now invite Professor Ganguly to speak on.
So just let me understand the composition of the audience a bit. So how many are from humanities background? All others are from science? Okay, yeah. Science background, everybody else? Oh. And how many of you he knows the basics of machine learning, which beyond what Ravindran told in the morning? Anyway, I think Ravindran has made my work a little bit easier. So, feel free to stop me. Okay. So, I will tell you something a little bit technical, but try to have it as lucid as possible and you can stop me. So, I have also asked for chalk so that we can also do something on the board if needed. So, I will talk about pre-training. So, let me just get into the basics. I think Ravindran has told about this, that our task, machine learning may have various tasks, like classification can be a task. Okay. Classification of tasks, like classify whether a sentence expresses positive or negative sentiments. So, this can be a simple task. And for this, what you need some annotated data. Okay. And what does annotated data means? That given a sentence, positive, negative, neutral, so you need this type of data. The food is not worth the price. This is a negative sentiment. It is a total paisa usul. This may be a positive sentiment. The lunch cost 400. So this is a neutral statement. So you need a lot of annotated data. Someone has to annotate there. So there is no free lunch as such. So some human has to annotate this data. And once this annotated data is there, then there is some magic called machine learning, which will look into this and then later will classify, given any sentence, whether it is a positive sentence or negative sentence. So is this basic premise clear to everybody? This is the basic premise on which machine learning works. Okay. So if you have this in mind, if you have this basic premise in mind, let us see the issues, the problems. Okay. So the problem is, it's not that this is much easy, means you need a lot of data. So this, with 3 sentences, this will not work. You have to have such type of annotated of thousands and thousands of sentences. Only then after that, a machine will begin to understand. And this has become more when we have this entire paradigm of deep learning. Okay. Entire paradigm of deep learning, which you need not bother too much, which is called an end-to-end learning sort of things, which is very data hungry. So you need a lot of annotated data to really get a good result. Okay. So again, nothing comes for free. You may get good results, but you need a lot of data. Somebody has to carefully curate to get the result. Okay. So this is the issue, and if this is the problem, we can immediately say that this is a costly thing. And so now if I just go, so there can be generalized tasks like sentiment prediction of any words, or there can be various specialized tasks. Okay, specialized domain specific tasks. Okay, so like I'm giving you some of this task. Let me just talk about some of this task. Say customer support domain. Okay, customer support domain. So previously in good old days when there was no internet, when you are buying a fridge, what would come with it? It will come, a manual will come. And any problem, you go to the manual, check it and try to find out how to fix it. Okay. So there was the manual. Now there are e-manuals, and what you need, not only need the e-manual, you need a service like question answering over that. You'll ask, you are lazy now, you don't want to go into the manual and check it. You want to ask a question, oh, my fridge is tripping for the last 3 hours. What should be done to fix it? And I want an answer from the email. So this is like question answering. I'm just trying to enumerate some of the tasks, very language specific tasks, which we want to. Or if you think in financial domains, we may have various things like as of December 31, 2020, we had a cash equivalent of 24.8 million and a closing stock price of 18 million per share. So now people may ask, what is this 18.2 million? Financial experts understands that this is a debt instrument convertible conversion price, okay, which is a very technical term. But now machine wants to understand, or we want the machine to give us back that this number actually is referring to debt instrument convertible conversion price. So this is a task. So this is task many times we called as named entity recognition. So you are trying to understand the name of an entity, something like this. Okay. Or if you think legal domain, we want to do clause span extraction, that exactly which clause and the span of which clause will help you in R. So that's what you are trying to find out from the legal domain. Or if you take biomedical domain, there are several tasks like named entity recognition. You want to find relation extraction, that which cause effects, which medicine is having which cause. So all this you want to find from biomedical literature, or question answering, etc., etc. So I hope I am just impressing upon you the vastness of these topics and the difficulty of these tasks. So difficulties they are very domain specific. If you think otherwise, they will need specialized people. If you have to do this financial domain, you have to have financial experts to help you. If you have a TV broken, then you have to call the service center and get it. So all these things are now would be done by this task or by this service. Okay. So again, just remember what I told. All these things may be a classification task. Let us put this in the broad umbrella of classification task, but they will need a lot of data. Okay. And the problem is there that since these are specialized things, the data by itself is small in size. Okay. And if you have to create this data, it's like annotate. How will you annotate thousands and thousands of sentences with positive and negative sentiments? Can you come up with an idea? How will you annotate? The first problem I gave, that there are positive and negative sentiments. So how will you annotate thousands and thousands of sentiments and check whether they are positive or negative sentiments? Give me a plan. Now I want to annotate. I don't want to follow any rule. I want to annotate. I want to annotate it using people. Means one person will see this sentence and tell, oh, this is positive sentence. The next person will see a sentence, will tell this is negative sentence. Huh? So sorry, I will step back a bit. So it is human annotation, simple human annotation. So I will give it to humans. There can be various rules, not can be in a various different ways. So we don't know the rules. I will give it to humans, and humans will annotate it. Okay. So now tell me, how can I do it? So if you are told to do it here, perhaps 1,000 sentences, you will tell, okay, the last bench do 50, say they do 50. In this way, you will distribute it. This is how you will do. Any other method you can suggest? So this is a plain human work. This is a plain human work. There is how human interpret positive, negative sentiments, I don't know. Every human is doing this task independently to create the data. So now the only way you can is to distribute. And now there are various internet services where you can give it to people. You can give it to people so that people do it. There are various internet services where people come, their internet platforms like Prolific, Amazon Mechanical Turk, where you submit the job and people from all over the world comes and does the annotation and get a small money. Okay, get small money. This is how annotation goes on. But let me just think back that what is the guarantee that the human will do it correctly? What is the guarantee that the human will do it correctly? Or what is the minimum requirement that the human will do it correctly? What is the minimum requirement? Yeah, means a basic understanding of language is necessary for the human to do it. And then it can be so and we understand that there is a lot of people who has a basic understanding of language. So I would feel comfortable to, so I can safely assume the people in this room have a basic understanding of language, and I can give 50 to everybody, and more or less there may be some mistakes here and there, but more or less the annotation will be correct. But now think, I give humans, these people, I give to give a judgment and tell that find the clause exactly in those books where this judgment actually the judgment has originated from which clause of the legal document. And if I give 50 out here, what will happen? Huh? Everybody will make mistake. At least I will make all the mistakes. So this is something which actually is unreliable when annotated on large scale. So when we try to do some sort of crowdsourcing on this type of specialized task, it is not possible. Okay, because these are very specialized tasks and it needs experts, and as soon as you employ experts, it is actually costly. So these becomes immensely costly. So if you try to annotate these things, this becomes immensely costly. So there is always a possibility, there is always some sort of opportunity that you can automate this type of difficult services. You can automate this type of difficult services, but always there is a cost, the opportunity cost. There is a huge opportunity cost that you have to have huge amount of money to do it. And if I think from very practical ROI point of view, it is not clear that ROI would be good or not. Okay, understood the point? So now with this concept in mind, let us think about pre-training. So now can we circumvent this situation? So the basic thesis is, can we leverage unannotated dataset to reduce the need of annotated dataset? So what is the unannotated dataset? Okay, so unannotated dataset is there is a lot of say legal documents. Means legal documents are freely available. Okay, all the now judgments are online. Okay, all the judgments are online. There is life law is judgment. The constitution is online. Okay, the legal history is online. So there is a lot of unannotated data sets. So this is the opportunity that there is a lot of unannotated data sets. Now, can we use these unannotated data sets to reduce the need of annotated data sets? I hope you're getting the point. Huh? So now, if we can understand the semantics of unannotated data sets, it may help in quickly perform a specific task. So if we now we are students, we are not understanding anything about legal things, but we begin to read this. We begin to read this legal documents. Okay, we may not get head on tail of anything, but if we go on reading, some idea which will come within us that may help us in doing the annotated task, or that may help the machine in performing the annotated task with much less amount of data. Okay, so now I will give you something which is my favorite example. It's like when you are as a kid, when you are told that you have to write good essays. Okay, so if you have to write good essay, what is one of the prerequisite of writing good essay? Tell me. Say you are writing good English, Bengali, whatever vernacular essay. What is the prerequisite of writing a good essay? Yeah, so reading books, story books, see, this is a common prescription that if you have to write good essays, you have to read good story books, read all sorts of things, read the newspapers. Okay, so these things if you do, then immediately that may impact your capability of writing good essays. All of us agree with this? Now think carefully, okay. When you are reading story books, are you reading story books with the idea of writing good essays? So this is a completely different task. This is a completely different task which you are doing, and this is a complete different sort of learning which you are doing, which is task independent. It is you are reading books because you love books, you are enjoying the books, you are reading the books. You are reading newspapers because you want to know the world, you are reading newspapers. But this has nothing to do with the end task of writing a good essay. So I hope you are understanding that this is two completely different things. But as soon as you do this task independent learning, your task dependent learning becomes much faster. A person who reads books will surely write better essays than a person who memorizes maybe 100 essays and come. Okay, even if you memorize 100 essays and come, you will perhaps not write as good essays as this. So this is then what? So now frame it back to the old thing that we have not many good essays, but we have a lot of good books, lot of unannotated data. And if we know a lot of unannotated data, then the annotated task becomes much easier. Okay. So again, one simple thing I will tell that say Chennai is a place where many have come from the north. Okay, from the north, from the east, from the various other states. Okay, so and say let us take people from north. Okay, they have come in various professions. They have come in various professions in Chennai. So some has come as a academician, some in industry, some are taxi drivers, some are doing in the markets. Who learns the language best? Tell me, which profession people learns the language best? The Tamil language best. Huh? Yeah, merchants, drivers, these are, and are they taking any formal course? They are not taking any formal. They listen, and they learn. Okay. And first they learn the basic, so we call it basic supermarket level language. Then they begin to understand sentiments. Then they begin to understand the expletives. Then they begin to understand all sorts of various nuances of the language. And just by listening. No other learning. If you think carefully, there is no other learning. They are listening, listening, talking, and this way. So there is a learning and generations, and you begin to actually learn. So this is a very, very simple way how you learn languages. And you see, the dumbest of the dumb person also can speak. Okay. So he may not be able to say what is 2 plus 2, but he will be able to speak. So this is how language goes, and this is what we want to actually replicate in the machine learning phenomenon. This is what we want to replicate in the machine learning. And this is what is called pre-training. We were doing a training, but this is called pre-training. So let me see how to pre-training works. So pre-training is a very, very simple thing. It is so you perform a simple task of self-supervision. So the point is that quick brown fox jumps over the lazy dog. Okay, and you do one simple thing. You mask this. Mask fox and tell the machine to predict it. So initially the machine will make mistakes, but if you go on doing it millions and billions and trillions of times, the machine will slowly begin to guess rightly that this is fox. And when it is guessing rightly, it is not just guessing. It is also understanding the semantics. It is understanding how grammar works. Okay. Somehow, internally, it is begin to understand how grammar works, how the semantics works, how the words are put. Okay. Even slowly, it begins to learn how the sentiments are there. So this is how the language learns. And see, the interesting thing is you have the data. Do you have annotation here? Think carefully. Do you have annotation here? What is the task? The task is fill in the blanks. And you know what should be filled up. So you have the annotation. You know what should be filled up. So you have the annotation. But this annotation need not be created by expert. This annotation is coming from the sentence itself. So that's why this is called a self-supervision model. You are supervising, but on yourself. You are supervising on yourself. And once you do a lot of this, you gain structural information, semantic information. And once this is learned, then the other tasks become much easier. Okay. So with this, I will give you one simple example to understand. So this is perform some billion and some sort of understanding of language emerge. We don't know what emerges, but and this is called mask language model. So use this to perform specific tasks. So let me take one specific task and tell you. Okay. So what happens? So I am taking this specific task and trying to make you make a case. Okay. So this is question answering over email. I've told you this. So this question may be, how can I encrypt my SD card? Okay, how can I encrypt my SD card? And it may be that you have to, the answer is somewhere here. So answer is from setting biometric security, encrypt, etc., etc. And then you have to see some sort of decrypt here. So the answers are, then how can I save my selfies without flipping them? So these are some of the questions I can ask. How can I save my selfies without flipping them? So this is a question I am asking. So now say this question is complex. It has multi aspects. So this question is not an easy question. Okay. Even if you ask an expert, he or she may fumble a bit. Okay. It's a multi aspect. Now the answers are multi-sentences. So you have the sentence for the setting and non-contiguous multi-span. Okay, it is not a contiguous span that, okay, it is there. It is a non-contiguous multi-span. Okay. So I just want to impress upon you that this is a difficult task. So there is some sort of, you have an e-manual, you have to go to a section, and within that section you have to find an answer. So it is a difficult task. It's a difficult task. All tasks can be done. Only Holy Grail is you need data. But here you will have very less data. That such sort of sentences, I think we have 1,000 such sort of question answers, just 1,000 annotated points. So such difficult task with 1,000 question answers is very difficult. Okay. So let me take it this way. So what happens is there is a section which contains annotated answer and then the annotated answers. So what we have to do, we have to first find the section, and then within the section I have to find the answer. This is how things will go. From the section I have to. So now here we do a interesting design where we say that this is a multitask learning objective, where learning the section would impact the answer and learning the answer will impact the sentence. So you design a multitask objective. Although these tasks are like pipeline task, one task after another, but we design it in a multitask framework. Okay, we design it in a multitask framework. So somehow the machine tries to help learning the answers from the sentence and learning the sentence from the section and learning the sections from the answers. So this way you build up a multitask framework. This is very nice design, but again all these designs holy grail is data. So moreover, whatever complex design you do, you need more data to train. And simply we don't have any data. And what does training means? Let us think what does training means. Let us try to devise, or let us try to formulate what does training mean. Training means, so this is a network. Okay, this is a network with weights. This is a network with weights, like brain network with weights, and you are updating the weights. You are updating the weights at certain weight level. It seems okay, it has learned. Like our brain at certain weight levels, we think it has learned. And what we have to do, we have to start from initial random weights and go to that weight. Okay. So from random weights, we go to the learned weights. Clear? So yeah, I can stop it because you think over, because you are going from random weight to the learned weight. This is what you are doing, and this is what is called learn. And from random weights to learned weight, this is a long journey. It's not a small journey. This is a long journey, and a lot of iterations is needed to go from random weights to learned weight. Okay. So now, how will pre-training help? So there is no pre-training here till now. So how will pre-training help in this case? So what we do, see the random weights, we have to go through these things. So now what we do, even before starting this operation, we collect all sorts of e-manuals which are present in the internet. And we found 300,000 e-manuals in the internet which has 1 billion sort of words. And we begin to train this with this simple masked language model. We begin to train this network with this simple masked language model. Okay, we begin to train this network with the simple masked language model, and like training it like this means that the defroster can be found at XX end of the refrigerator. the defroster can be found at the top end. Because you're masking one word, you're masking one word, that's why it is called masked language model. We're masking one word, that's why it is called masked language. Anybody has any question? So what happens when we do this on this data, on this network? So it doesn't stay random. Okay, it is in a situation which is I can call learned minus minus. Okay, and now think carefully. From here, if the distance is delta 1 and here distance is delta 2, then what we can write? That delta 2 is much less than delta. Think carefully, okay. So initially we could have random weights and we have to go to the learned weights. And what happens? That is a long journey, delta 1 journey. But what we have done, we will first do this and train the weights in such a way so that it is in a learned minus minus situation. Means it has moved faster. And now we just have to move delta 2. And delta 2 is much less than delta 1. Yeah. Yeah. So that is something which we are doing through this technique.
Okay, so does that come in when we calculate the deltas?
Yeah. So this is delta 3.
So what is the relation between all the deltas? Is delta 3 greater than delta 2?
No, that we don't know.
Okay.
So delta 3 may be very low. Say it can be, we really don't know. Delta 3 can be even greater than delta 1. Okay. But we don't care because we have enough data. We have data. We have annotated data. So I don't care. I am taking 300,000 and running the system. I am running 300,000 running the system. So what data is scarce? Unannotated data is not scarce. Annotated data is scarce. So I don't care if I have done very inefficiently there. I have read storybooks for 10 years. After that, I am writing a book or I am writing a essay. Doesn't matter. I have read that. I am come to a learned minus minus situation and then I am starting. So this is the holy grail of all large language models, that you are training the model on a unannotated data sets and on task independent, means there is no target independent task. So this is not a task where there is some target that you have to answer some questions. This is just self-learn. This is self. So I hope this design part is clear. Yeah, so see, the point is when we are doing this task, when we are doing the task of question answering, that means it is at certain learned state. And initially when we don't know anything, it is random. Now we are doing this pre-training sort of things where we are at least learning the semantics of the e-manuals, that is bringing us into a learned minus. Okay, so and what we are saying, the journey from learned minus minus to learned is a smaller journey, and a smaller journey translates into smaller requirement of data. Ultimately, remember everything, data is important. Data is the most holy grail of part. So technically, there are various challenges, but if you have millions and millions if you have abundance of data, now as you have heard that there can be trillion parameters, okay, there can be trillion parameters and it can be actually trained. And we know the famous thing, I think, give me 4 elephants, 4 parameters and I will fit an elephant into a room. So this was the initial understanding, and now we are going with trillion parameters. So that type of learning is not difficult. Okay. So, yeah. So I have just written from weights obtained from pre-training, which is learned minus minus. And we actually show, this result is not important, but once we do this, the results improvements are huge, like 0.42 to 0.6, 0.22 to point. So it's 50% improvement immediately we are getting on same task, same strategy, just adding the pre-training module to enhance the task. Okay. So, any question here?
So what does Roberta encode architecture mean?
You need not bother about this. So, there are various encoding architectures like BART, Roberta. Okay. So, yeah, but this is a specialized type of architecture. This is very technical, but BART and Roberta are some very popular architectures in machine learning. Okay, which encodes. Huh.
Does pre-training overall decrease the total amount of computation required to get a decently accurate classification?
See, you are So, how many have done sorting and searching? Okay, so let me ask. This is a popular question which we ask. Say, what is the time complexity of sorting? What is the time complexity of sorting? Who knows, huh? Huh? No, it doesn't depend upon the algorithm. Okay, take a decent algorithm. What is the time complexity? N log n. Okay, and what is the time complexity of searching? Log n. Okay, so let me write this. So n log n plus log n. Okay, and what is the time complexity of searching a unsorted data set? Unsorted data set. And okay, so this is T1 and this is T2. Okay, tell me which is bigger, T1 is bigger or T2 is bigger? Huh? See it and tell me which is bigger, T1 is bigger or T2 is bigger? T2 is bigger. How? T2 is n and T1 is n log n. Immediately I see T1 is bigger than T2. T1 is just n and T2. So, is there any doubt, even those people who are humanities people, any doubt that T2 is greater than T1? T2 is less than T1? Is there any doubt? This is class 5 level or 7 level or 8 level maths. That T2 is less than T1. Then, should we sort to do search? Should we sort to do search? You understood why? Huh? But there is no free lunch. Huh? Somebody has to sort. Somebody has to do this task. Then we should not sort before searching. So nobody should keep your rooms clean. Huh? It is much easier to find things when the room is not clean. Yeah. I'm accessing elements. When you are searching, you are also accessing elements. So then why should I sort to search? But still it will be n log n. At most this will go. At most this will go. Still it is less. Still it is greater. Then should we do? So the conventional wisdom tells that we should sort before searching. Why? Should we keep our rooms clean or not? Why? Not just for the aesthetics part, or there is a functional importance of that you can search well. but I'm mathematically showing that that is more costly. Why should I why should I go for an inefficient thing? I'm mathematically showing that. Very good. So once you sort, this is a bad way of showing. I have to write it this way, that log n k, okay, and where k is a big number. Okay, k is a big number, where k is a big. Okay, so you sort once you clean your room. If you don't clean every time you are searching, you clean and then you go on searching. So you sort once, you search many times. Similarly, here you pre-train once, but task specific things you do many times. So as soon as you have read books, it's not only used for writing essays, it can be used for an interview. It can be used to have an interesting discussion for your date. Okay, it can be an important instrument for your date. So that people talk some, oh, I have read this book, however, to prove how intelligent you are. Okay, fine. So you train once, you pre-train once, but you use it many years time. So it doesn't matter if delta 3 is greater than equal to delta 1, because this weights you will use for other tasks only, not only this task. Is it clear? Okay. So this is how I really get excited about this sort of learning, because this learning is very human sort of learning. How machine is using is a very human sort of learning. How? Okay. So now let me dive a little bit into the design part. So one problem again, this is a problem, that delta 3 is a problem. That it's huge time, and people were talking about how much time how much carbon footprints are there, and this, in order to perform these tasks, Google etc. are putting the servers in Alaska so that you don't use, it was to avoid the cooling thing which they needs to do, but it's a huge exercise. Okay, so one of the important design perspective would be to learn early. And I can give you some examples, like if I think of various sorts of domain specific things, I was seeing that, see, these have huge amounts of words, 13 billion words. Okay. And like a BioBird is not even a big model, it's a small model, but it takes like 23 days of 8 NVIDIA V100 GPUs to continuously run to really get this learned minus. So that is a difficult thing. That's a huge thing. So let us dive back and think a bit. Okay. So what? I'll just. So when we were doing this mask language model, what was mask language model? Tell me. Yeah. Madam, you tell me. Yeah. So it is that quick brown fox hiding fox and trying to get fox. This is how, and you go on doing sentence after sentence after sentence after sentence, and you begin to learn. This is basic, very, very basic way of learning. So now I am trying to critique that a bit. Okay, I'll try to critique that a bit. So each sentence and documents hosting them are independent entities. So we are thinking that each sentence is independent of other sentence. So when I am doing quick brown fox, this is one sentence. Then the defroster is at the XX end of the refrigerator. This is another sentence. So all sentences are thought to be independent. And you are learning independent sentences. So in practice, it is not so. Okay, there are several documents which are very similar to each other. Like, say, manuals of a phone series. If I have a manual of Apple 10 and Apple 10.1, this would be roughly very, very similar. Or if I take movie review by different newspapers on a particular movie, okay, there may be a lot of sentiment difference, but the entities roughly will be same. The author or actors' names will be same. The sequences which will be told will be same. So there will be a lot of similarities in this. Or if I think scientific articles on pre-training, they will have a lot of similarities. So can we leverage document level similarity and also their categorization? Most of the documents can be put into some category. Like if I think e-manuals, these are gadget-based categories of electronic devices. So there can be some sort of categorization of these documents. So now I want to learn not by masking, but by contrasting. So many times, how do I know that the neighbor is a good boy? How do my parents tell that the neighbor is a good boy? How do my parents tell? See, he is doing so good. How does our parent tell? Because you are doing bad, huh? So this is comparison. So you learn through comparison. So you just learn through seeing. This is one way, but another much faster way perhaps is you learn through comparisons. Okay, you learn through comparisons. So and you also learn through some sort of categorization, which in real life we negatively say that you are typecasting people. Okay, because you also learn through categorization. Okay. So this sort of things we learn. So now can we leverage those things like document level similarity or comparisons and categorizations to learn? So now let us see this example. So say customer support e-manual. So you have a stereo equalizer e-manual, of a different brand, and a Blu-ray player e-manual as this triplet. This is called triplet loss in machine learning. So you are thinking triplets. If this is an anchor, stereo equalizer e-manual is an anchor, and you have a similar and a dissimilar document. You have proximal policy optimization examples, generating natural adversarial examples, because this is also some sort of optimization, while autonomous tracking of intermittent RF sources using UAV swarm is a completely different document. So now what you are learning that, okay, I am an anchor, what is similar to me, what is dissimilar. So some sort of contrasting I am doing. And then I am learning the basic semantics. The basic semantics, here I am learning through comparisons. Previously I am learning through masking. Now I am learning through comparisons. And also some sort of supervision. See, stereo equalizer has an hierarchy. It is an electronic gadget, an audio gadget, an audio player and recorder, and a stereo system. And this type of hierarchies are already developed. This type of hierarchies, this is a Google hierarchy, is already there. So all these documents can be, most of the domain specific documents can be put into some sort of hierarchy. Like a scientific document is a computer science machine learning document, or a legal document is on agriculture, product subject to market organization, and oils and fat. So it is a agriculture related document. So we are learning in two ways. One is through contrasting, another to typecasting. So once we learn systems, or once we pre-train systems, using these two simple things, we can see that there may be a lot of, we can see that there can be a lot of compute, means we can learn much faster, and there can be cases where we are learning even 1,000 times faster. The same thing which we would have tediously learned every sentences, here through just the sort of comparisons, we are actually learning 1,000 times faster. Okay, so this is a frugal sort of pre-training which leverages document level semantics and shows dramatic improvement, and it may solve the requirement of huge compute, which is one of the problems of pre-training model. So yeah, I can I take 5 minutes? Okay, fine. So I will give you one last example, because this is also very nice in one way, that what do we do where semantics is not available. Like, we are talking about languages. Languages are basically strings. And what type of, when we are doing masked language model, forget this part, let us go back to the masked language model. What semantics are we leveraging? What semantics are we leveraging? We are leveraging the semantics that fox is a word. Fox is a word, is a semantics, or is a world knowledge which we are actually using. What happens if we don't know that fox is a word? What will we do? And this specific problem comes when we talk about genes. So we are to, I think Ravindran was talking about alpha folding, gene folding sort of thing. So gene also is a long sequence. Okay, it's a long sequence of string, and genes also. So there is obviously, since it's a long sequence of string, all the advantages of pre-training on language, people would try to actually use it for genes. Okay, so now let me get into this. So when we mask here, what would be the easiest way to mask? Since we don't know any semantics, what would be the easiest way to mask? Tell me. Or what would be the more rational way of masking? When I don't know that fox is a word, okay, what would be the most rational way of masking? Randomly you mask some. So that is the most rational and the only way to mask, that you randomly mask some genes. Okay, you randomly mask some genes or tokens. So if you randomly mask some genes or token, how will that translate into the original masked language model? Let us think this. Okay, so we have masking fox jumps over the lazy dog. So now what will we mask? If we randomly mask, we'll mask N and FO. What would happen if we mask N and FO? What would happen if we mask N and FO? What do you think will happen? Go back to our e-manual. Think that instead of top, I have taken the last word here and two last letter here and two letters here and masked. What would happen? Will you learn? Will it learn? Will the machine learn if we do this? How many things the machine will learn? And how many things the machine will not learn? Okay, how many things the machine will not learn? Only 3%, 4%, 5%. How many things the machine will learn? You are not learning to learn. 1% is no other person is for learning. Yeah, your logic.
So according to me, it's we who know the meaning of a word and we are giving it a sense. However, the machine does not know what that meaning is, or it will take it as a string only, right? So according to me, it will learn.
See, the machine will still learn, But if you give such sort of things, then machine has an extra task of understanding whether it is a word or not. Previously, you were giving word by itself, so the machine didn't have to do this extra task of understanding whether a word is given or not. So what will happen if you do this? The machine will go up, then machine will require a much more data set, which machine will require much more data to learn. Because this becomes a very difficult problem, because this becomes a very difficult way of learning. Okay, so machine will still learn, but machine will now require much more data to learn. Because it has to first understand, see, it is one step down, that it has to first understand, oh, this is a word or this is not a word. Like when you listen to foreign languages, first you have to understand each word. See, when you listen to any foreign language, you see it is going so fast, you cannot even catch that. Okay. Fast, even one word going, you are listening 5 words, you are not even understanding it, whether these are 5 words, 4 words, whatever. So that step it has to go through. While in the masked language model, we were going through that step. Okay. The second thing is, what happens if I mask thee? What happens if I mask thee? What would be the impact? So these are very easy example. So what happens when you mask? So if we go on masking easy examples again and again and again, the learning will be limited. So if you go on masking easy examples, the learning will be limited to certain patterns. So that's why this is again an interesting example. So when you are doing like physics during your class 12, and you have all these questions which spans from easy to very hard. So it's always told that you do the middle part, not very easy, not very hard. The middle part makes you learn the fastest. Middle part makes you learn the fastest. So here, as soon as you don't know the semantics, you run into the risk of learning very difficult things or learning very easy things, which both will hinder the learning process.
So in the previous example, you said that there would be an extra task of identifying whether it is a word or not. So according to me, that would be a situation when the model is trained to some extent, right? However, if it is in a starting phase, or if it's something like alpha masking, where say we are starting from the scratch, we don't know what the word is, or we don't have any basis of identification, then what would happen in that case? It will take it also as a word, right?
See, that's what I'm telling, that understanding whether a masked span is a word or not, this is an extra task you have to do before you reach that level. When you are doing masked language and masking a word, automatically you are masking the word. So inside this system, already we are imbibing the knowledge that we are masking a word. Here you have to reach that level, then you can compete with this.
Thank you, sir.
So I will give you another example. So training steps are wasted either too easy or too difficult. So easy is some other example. So say if I mask this, what is this? Everybody knows this is New York. So this is a very easy example. So what you try to do is, you don't mask I live in dash York. You should mask the entire thing. Sorry about this. You have to mask New York completely. Okay, so this is what you do. You try to actually. So anyway, there is the concept of mutual information. I am not going into the details. Techniques to identify such frequent co-occurrence and mask all together rather than mask one of them individually. So this is how you train the system, and you can see that as soon as we train this, there was a system like DNA BART, which was taking 120 key steps, and with this simple way of training the system so that the system learns faster, we have reduced it from 120K to 10K steps. So it reduces 112. Okay. And the results also fold to certain extent. So I think I have given enough time for the cook to prepare the lunch. So the summary is we have a substantial speed up and incorporating domain knowledge then there are various other things which we can do. This is an entire field which where the concept of learning, cognition, and machine learning, machine architecture, everything comes together, and let us make things much more efficient and deployable so that it becomes easy for people to use. Okay. So I think I have told enough. So thank you. This is group, and thank you. Any questions I am open to ask. Open to it.